Okay, I know what you're thinking. You're thinking, Mr. Schneider, how did you get to be so awesome? Well, hey, we're doing math now. We can always talk about how awesome I am another time. Okay, so now here's what we do. Right now, what you're given is you're given this mega fraction that looks way too hard to ever reduce, and you're mad at me, like, Mr. Schneider, why are you making me reduce this mega fraction? Well, good question. The reason why is because I'm not making you reduce the mega fraction. All I want to know is if 2 can go into it, 3, 5, or 10 can go into it. Okay? That's it. I don't want you to reduce it. I just want you to use the basic divisibility rules for 2, 3, 5, and 10. And you should not have to divide it all to get these. And I want to make sure that we know these basic rules and we're old pros at them. So let's go through. I have 3,474 over 2,988. Look at the first one. This is divisible by 2. Well, is it even? Does it end in a 2, 4, 6, 8, or 0? Well, this ends in a 4. That's even. This ends in an 8. That's even. So therefore, it is divisible by 2. I'll check that off. Now, let's look at 3. So to check divisibility by 3, what you do is you add up all the digits and see if that's divisible by 3. 3 plus 4 is 7. 7 plus 7 is 14. 14 plus 4 is 18. Oh, 18 is totally divisible by 3. But if you didn't know if it was or not, just do it again. Do 1 plus 8, and you get 9. Oh, 9 is divisible by 3. So 18 is divisible by 3. So 3,474 is divisible by 3. But you got to do it for both. So 2 plus 9 is 11. Plus 8 is 19. 19 plus 8 is 27. Oh, hey, that's divisible by 3. But if I didn't know if it was, just add them up again. 2 plus 7 is 9. Totally divisible by 3. So, bam. Now I'm going to clear this off so I have some space. Now, is this divisible by 5? Well, if it's divisible by 5, then it ends in a 0 or a 5. Neither of these numbers end in that, so nope, not divisible by 5. Finally, divisible by 10. Now, if it's not divisible by 2, then it can't be divisible by 10. And if it's not divisible by 5, then it can't be. But if you don't get that, then just know that 10s end in a 0. Neither of these numbers end in a 0, so it's not divisible by 10. There we go. Hey, we just talked about a number ending in 0, so I can just start from the bottom now. I'll be here. So, for 10s, it has to end in a 0. This ends in a 0, and this ends in a 0. They both have to end in a 0. So therefore, I can check off the 10 box. In fact, I can look at this again and say, wait a second. If it's divisible by 10, it has to be divisible by 5 and 2. Because 2 times 5 is 10. But if you don't get that, then take a look. 5 ends in a 0 or a 5, which this totally does. And 2 needs to end in an even number, like 0, 2, 4, 6, or 8, which this totally does. Now let's check out 3s. So for 3s, I do 7 plus 5, and I get, I know 5 plus 5 is 10, and 7 is 2 more than 5, so that'd be 12, plus 3 is 15, plus 0 is still 15. Good. So 4, and that's totally divisible by 3. 4 plus 7 is 11, plus 7 is 18, plus 0 is also 18. Nice. Which is divisible by 3. So therefore, this is divisible by 3. Okay? See, you don't even have to divide these to check if it's divisible or not. Last one. Oh boy. Let's see what we got. Well, I know that they're both ended in even numbers, so they're even numbers. So it's divisible by 2. Now let's check the 3s. I know that 3 plus 0 is 3, plus 6 is 9, plus 0 is, hey, also 9, divisible by 3. 4 plus 0 is 0, plus 3 is 7, plus 2, hey, also 9, divisible by 3. So these numbers are divisible by 3. Let's clear this up a little bit. Now let's look at 5s. Well, if a number is divisible by 5, it ends in a 5 or a 0. This one ends in a 0, but that does not. So therefore it is not divisible by 5, and they both don't end in a 0, so they're not divisible by 10. There we go.